function or neither. It is an exponential function because of this 3 to the x.
Yeah.
It's a growth function if that was important here. I wouldn't expect anything that kind of what we would call trivial to be on the exam because it's like a build up to the next type of questions. So the next ones here are, or next one here is, but kind of the same thing. Is it a growth or decay? There's a lot going on here with this. So kind of in review, if it's like 4 to the x, this is growth because the exponent is positive and this number here is greater than 1.
Yeah.
So we really want to make this a positive exponent. And to do that, you would flip the inside part. So it becomes 4/3 to the power of x. And then the question is, is this growth or decay? And it all depends on this number now. Is this number greater than 1? Yes.
Yeah.
So it is growth. And then growth functions always look like this. Okay, so as x goes to infinity, these are always written kind of, in my opinion, backwards, but as x goes to infinity, as you go to the right, f of x goes to positive infinity. See how this grows forever?
Yeah.
But when you go the other way, it doesn't go to negative infinity. As you go, this means left, as you go to negative infinity. As you go left along this curve, it approaches what's called, what I write as the horizontal asymptote, which is the same thing as the vertical shift. So notice there's a +0 here that isn't written. So that goes to 0. But more generally, it's the vertical shift.
Got it.
All right. Are you allowed to use a calculator on this test?
I don't think so.
Okay, number 3 is a calculator problem. Should we do it?
Yeah.
Okay. All right, the population of Scary Heights was 85,000 in 1900, and it has been decreasing at the rate of 1.25% per year. Okay, estimate the population in 1947. So I think one of the confusing things about this part of the course is that there's really 2 types of functions. There's pat, and then there's pert. They're actually the same, but like you got to be comfortable using either one. So depending on which one you use, do you know if there's been a preference for one or the other in this course?
I think it's pert.
Yeah, that tends to be the one that we would see here. So if it's decreasing at a rate of 0.125%, that means that your R is 1 minus, I'm sorry, I'm doing it for that one. Your R is negative 0.0125. Okay, and P is your initial amount. P is 85,000. So we have 85,000 E minus 0.0125 T.
Okay.
And that's not A, but that's like, hey, you got to write a function for it. So we want the population in 1947. So that's T equals 47 because 1947 is 47 years after 1900. So we want P of 47, 85,000, E to the minus 0.0125 times 47. That's why I asked if there's a calculator problem or not. And you get some number there.
Yeah.
That's part A. Part B, they want to know when it reaches 40,000. That's the left side. They're saying P of T is 40,000. The left side is 40,000. So you get 40,000 equal to 85,000 E to the minus 0.0125 T. This time you have to solve for T. We can do this without a calculator, but to get a numerical answer, we would need a calculator to help with this. So we divide both sides by 85,000. Okay, and this does reduce here. We want to do that. Yeah, let's do that, I guess. So 40 over 85, they're both divisible by 5. What is that? 8 over 17. So it's 8 over 17 equals E to the minus 0.0125 T. You take the natural log of both sides. We'll probably be doing some of these types of problems in the next section. our next question group. On the right, the natural log and the e cancel, so it's minus 0.0125t. And then you divide both sides by minus 0.0125. And that's your t value, whatever that becomes.
Okay, got it.
Okay. 4 is kind of a question it's not a repeat, but it's a more direct thing, because you're just solving a logarithmic or an exponential equation in this case.
Okay.
They say to solve the equation by changing the equation to logarithmic form. If it just said to solve, you would already do this. If it just said to solve for x, you would already know to do this. You take the natural log of both sides. Natural log is the only way to get a variable out of the exponent. On the left side, it becomes 2x. Right side, it's natural log of 75. Divide both sides by 2. So x equals natural log of 75 over 2. And this is the kind of question where you can do it and not necessarily have a calculator, because this is correct.
Mm-hmm. Yeah.
All right,
Okay.
let's look at the next question here. So when it comes to these like end of chapter tests, like there's a lot that goes into this particular question, like in terms of like where you are in stepping up here, like you're all the way at the top step, because this one has a bunch of transformations. It's actually got 1, 2, 3, 4 transformations from its parent function, y equals natural log of x. So the first one, and this is a little bit awkward, but it's negative parentheses x minus 3.
Mm-hmm.
If you do a little rewrite here. So the first one is usually left or right. You could do the flip over the horizontal axis as your first one. It doesn't really matter. I mean, you're going to get to all of them, but basically what I'm trying to get you to see is first, there is a shift right 3.
Yeah.
Okay. But this first negative on the inside, that's a flip over this axis. So you got to know what natural log of x looks like, which is this. And then you got to know, well, negative x means that it flips over this axis here.
Okay.
So it's a flip over the y-axis. And then this negative out in front, that's a flip over the x-axis. And then this 2 is up 2. So it's a vertical shift of 2 units up.
Got it.
So I actually think I have these reversed. I think we have to flip it first. So it over the y-axis. So you would flip it like this, then you would go right 3.
Oh,
Okay.
okay.
Then I kind of delete these as you go. Then you what did I say? Flip over the x-axis. So now it's this mirror like that, and then I delete it. I can delete it. You can't. Kind of unfair. And then up 2. So everything goes, up 2. So something like that. This is a hard question to do. There's a lot that goes into this. But really it's the y-axis flips that tends to get students confused, but then you got to do an x as well. You also should probably draw the vertical asymptote at x equals 3, because that's what makes this original function 0. And that's where it's undefined.
Oh, yeah. Okay.
You know the rules. It may just be a function of you maybe practicing this one or something like it.
Yeah, I think I got them.
If you're allowed to use Desmos, which I see in number 6, you can graph it as is and you'll get the right answer also.
Mm-hmm.
It's another possibility. All right, this one says to use Desmos for regression. So you must have a link to some sort of regression tool in Desmos.
Yeah.
Is that right?
Uh-huh. We can
Okay.
use the regression.
All right, I'll let you, I haven't used it, so I will be slow. Is it okay if we just move on to 7?
Yeah, that's fine.
Okay.
It's easy. You just put the things in the.
You get out the value that you need.
Mhm.
Perfect. Okay, so number 7 here, this is a standard type of question that you're going to see. It should just say expand. Let me just write over here. It'll say expand log 5th root 3y over x. And,
Mhm.
and then there'll be another problem that says to compress the logarithm. But for expand, there is a rewrite step here, which is you want to know how to handle roots. So as a reminder, the root of 5, there's really a 1 here that's not written, and then it becomes 1 over 5. You want to be comfortable matching, where those numbers go.
Okay. Yeah.
So the first thing I would use is the exponent rule for this, which is log base b x to the n equals n log base b of x. And in short, you basically bring that 1/5 out in front. So it becomes 1/5 log 3y over x. Then I would use the quotient rule, or I'm sorry, that's not what it's called. That's a calculus thing. It's called a product of sum quotient. It's probably called the quotient to difference.
That sounds familiar.
Yeah. And what that says is if you have log a over b, this equals log a minus log b. And it doesn't matter whether it's log or ln, it's the same property. So for your problem right here, it's 1/5 log 3y, because that's on top, minus 1/5 log of x. Now you may be asking, why is the 1/5 with both of them? There's really parentheses, and I just distributed to both.
Oh, okay.
So because it has to multiply both terms, so it's really, if there's a constant out in front, it would be constant and then constant.
Mhm.
And then there's yet one more for this right here, 3. This is called product to sum, and they also work in reverse. We'll see that for probably the compressed problem. So this becomes 1/5. Oops, actually need to write it out for you. If it's log a times b, this equals log a plus log b. And then c log, if you put a number out in front, it just goes with each of them. So for this line right here, it's 1/5 log 3 plus 1/5 log y minus 1/5 log x.
Okay.
You will for sure get something like that on the exam. Let me go and look and see if there's a compress. There's not a compress problem. So I could make one up, or we could just skip it. Up to you.
I think we can skip it.
Okay, very good. So let's go to question 8. 8 is a lot like 8 is a lot like 4. I think it's let me snip it in here. It says okay, this one just says to solve the equation. It could say solve the equation using exponentials, but you already know to do that.
Yeah.
Okay. So first thing I would do here is subtract 17 from both sides. -4 log x equals 8. Divide both sides by -4. So log x equals -2. What is the base? Do you remember the base when it's not written?
It's 10, right?
Yeah, so sometimes they don't write it, but it is log base 10. So the way you undo log is use 10 to the log x, and then you do it on both sides. And it's because these bases match
Mhm.
that they cancel.
Yeah.
So if you had log base 2 of x equals 3, you would write 2 log base 2 of x equals 2 to the power of 3. They have to match.
Yeah.
Okay, very good. Now that leaves just x equals 10 to the -2. I would probably expect that you need to be able to rewrite it like this, and maybe even rewrite it as 1 over 100, and maybe even write it as 0.01. but
Yeah.
this probably isn't full credit. Like you have to
Mhm.
remember that x to the minus n is 1 over x to the n.
Okay.
Okay, so that takes care of that. All right, number 9. Number 9. Okay. All right, how much greater was the amplitude of the ground motion in the 1990 Iran earthquake than in the 1988 Armenia earthquake? Two different R values. So what are they doing here? So they give you R and assume values of B and T are equal in both cases. All right, so 7.7 equals log A over T plus B. And then the other one is 6.9 equals log A over T, big T plus B. And they're saying B and T are the same in both, which means you could set them equal to each other. We're going to eventually want to divide these problems. Like there's a step here to like compare the magnitudes of each of them. And I think we can do this by, I was going to set them equal to each other, but I'm not sure that that's the right approach here. Another approach here is we could try to figure it. Like we don't have T and B and we don't have A either. I guess I don't know why. Oh, I bet A is the amplitude. Okay. A is the amplitude.
Oh.
So, did you get any questions like this in your assignments up until now?
I think so.
Okay.
But I have like math is my last class, so I can go in and talk to her if we don't know how to do
Well,
this.
yeah, it's like in both cases, if you set them both equal to B, let me get this down here. So it's log, well, let me try to decide how to write this. A. Sometimes I can just tell you how to do it compactly, but this one I'm struggling with that. So it's log T minus log A plus 7.7 equals B. And then over here, that equals 6.9 plus log T minus log A. And that's why they don't want you to do that. Okay. Yeah, why don't you ask your instructor? There's something here that's not clear to me that reason I can't help much for this.
Okay, no problem.
So we'll see if there's another possibility. All right, number 10. Okay, solve the equation algebraically. First thing is to clear the 2. So this is going to equal 15. And your instructor was kind enough to say u equals e to the x, which is great. All right. And so what that means is e to the minus x. Okay, if you were to raise this to -1 and this to -1, that's what this becomes. So let me write this again. That means it's u to the -1, which is 1 over u equals e to the minus x. Do you see that?
Oh, okay, yeah.
Okay, here's why that's important. You are not comfortable solving this equation as is, but by doing this substitution, that there's a chance that you can do it.
Uh-huh.
All right, now this doesn't look any better, but there is a technique here for solving this, which is to multiply everything by u. You get u squared minus 1 equals 15u.
Oh,
And then you move this.
factor.
Yep, u squared minus 15u minus 1, but this one doesn't factor real well. So you got to use the quadratic formula. So u, and that's what I was hoping. Just look at this, u squared, yeah. Sorry, it just doesn't work out.
Doesn't factor.
Yeah, so we've got your a is 1, your b is minus 15, and your c is minus 1. So u equals 15 plus or minus the square root of b squared. That's 225 minus 4 times a times that, all over 2 times a. So this becomes 15 plus or minus the square root of 229, which I think is a, excuse me, I think that's a prime number like that, but that's not our final answer, unfortunately.
Yeah.
The answer is that you have to go back to what your u is. Your u was e to the x, see right up there. So if u is equal to e to the x, then e to the x equals 15 plus the square root of 229 over 2, and then 15 minus the square root of 229 over 2. Now there is a small problem with this second one, because the square root of 229 is bigger than 15, so you get a negative number here.
Oh.
And when you solve, when you x is equal to the natural log of this thing, you can only take the natural log of numbers greater than 0. So this one is actually excluded.
Okay.
But this one is okay. But again, you need a calculator to do it.
Yeah.
How are we doing on this? Are things clear? Are they?
Yeah, this chapter is pretty straightforward.
Okay. All right, so again, like if you don't know the substitution, maybe ask on the exam, but you can't do it otherwise. You'll just be there forever.
Yeah.
Okay, solve the equation algebraically. So to do this, we actually need to first compress, because you really want the natural log of something to equal a number, or in some later problems, the natural log of something to equal the natural log of something. But this is the case we're dealing with here, where you want to get the natural logs compressed. And to do that, you have to undo the rules we did before. So like the first thing you undo is this power rule. So this number in front becomes the exponent. So if I bring this down here, natural log 2x minus natural log of 7x plus 15 to the 1/2 power equals 0.
Yeah.
Now, we know that the natural log of a minus the natural log of b becomes the natural log of a over b. And that's what we're going to use here in this problem. It's going to become the natural log of 2x over 7x plus 15 to the 1/2 power equals 0.
Okay.
Now, how do you undo ln with e?
Yeah.
So this becomes 2x over, and this time anything of the 1/2 power is square root. So it's square root 7x plus 15 equals 1. So algebra 2, you knew how to solve this. You end up having to clear this on both sides. So you get 2x equals the square root of 7x plus 15. Square both sides. 4x squared equals 7x plus 15.
Oh, great. Another one.
Yeah, this one might factor. I don't know. Let's see here. So 4 times minus 15 is minus 60. Something that adds up to minus 7. Boy. The other approach here is to guess and check. Okay, so 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. Okay, so there we go. Those are the ones we want. So it becomes 4x squared minus 12x plus 5x minus 15. We don't need this guess and check here. So you can factor out a 4x from the first two. That's x minus 3, x minus 3, and then a 5 comes out. So you get 4x plus 5, x minus 3 equals 0. Now you feel really good. You're like, okay, I got it. X is 3, x is minus 5 over 4. But if you go back and look at the question, it says, oh, we're just a long way up. List any extraneous solutions and explain. So we have to check these.
Okay.
And the mistake, you've probably heard me say this before, the mistake is to think, well, the negative one doesn't work. The negative one doesn't work because when you try it in the problem, it doesn't work, not because it's negative. And what I mean by that is we're going to go back to the original. I'm going to snip it in here. And you literally just like check, like, is the thing okay? Like, is the natural log of 2 times 3, is that okay? Minus 1/2 the natural log of 7 times 3 plus 15, is that okay? Yes, it's okay. Because it's positive inside. But you can see right away, 2 times negative 5 over 4, that's bad. Because you cannot take the natural log of a negative number. That's the way it's defined. So the extraneous solution is this 5 minus 5 over 4, and you'd want to say, when you check the answer in the original question, it doesn't work, or it's not valid at negative numbers.
Got it.
Okay, moving on to number 12. All right, now referring back to the first problem we did today, it asked if something was exponential. I think it also said logistic. This is a logistic model.
Yeah.
Okay, what is the population at time t equals 0? That just means put 0 in for t. It doesn't mean the whole thing is 0, you're just evaluating at 0. So it's 3886 over 1 plus 57 e to the 0. E to the 0 is 1. So this is 3886 over 58. And again, I mean, a lot of these do require a calculator. I mean, your instructor can make it nice. They could put, like, I don't know, 1/16 in the numerator, and then it makes 2. But I would recommend asking you to figure that out, because it does, it does change things.
Exactly.
So there's 67 rabbits when this problem starts in this fictitious world. Okay. Part B. Part B says, when will the population reach 1500? That's P of t. That's what P of t equals. So we set the original function equal to P of t. Or the thing on the right hand side. So it's 3886 over 1 plus 57 e to the minus 0.08 t. Okay, and this one's quite bad, but it's doable. I mean, you should be able to do this. You multiply the left hand side by this 1 plus 57 e to the minus 0.08 t equals 3886. Okay, and then you distribute in 1500 plus, and I'm going to use a calculator because I don't know that right off the top of my head. 1500 times 57. So 85500 e to the minus 0.08 t equals 3886. Subtract 1500 from both sides. 85500 e to 0.08 t equals 2386. Divide. By now you can probably see the next step is to take the natural log. So you get minus 0.08 t equals natural log of 2386 over 85500. Divide both sides by minus 0.08, and you get some number.
Okay.
If you don't get a positive number, you should just check that your signs are correct. That's one way to know if you've got the right answer or not.
Got it.
Okay, so to do part C, we actually just have to go back to the original function. And this is part C. To do part C, what happens when t goes to infinity? Basically, as you let time go forever. And really what I'm asking you is, what is e to the minus infinity? What does that equal?
I have no idea.
So this is 0.
Oh,
Because the graph of this, e to the minus x, goes down to 0. Do you see that? So this right here goes to 0.
okay.
So when t goes to infinity, this becomes 3886 over 1 plus 0. So when it asks, well, what is the significance of this number? This is what's called the carrying capacity, or it's like the number that it will eventually reach.
Oh, okay.
All right. I mean, I like that question. I don't know that. I mean, there's parts of it that seem like really on, like evaluated at 0 and solve for it, but part C kind of seems a little bit out of scope.
Yeah.
All right. Question 13. 13 is if Sandy invests $4,600 in a savings account with a 10% rate compounded monthly, how long will it take until the account has a balance of 6,200? So there's two types of, oops, sorry about that. There's two types of problems you're going to see. One is continuous, and that's PERT. The other is non-continuous, and these are more realistic. This is the P1 plus R over N to the N times T. That may be why your instructor said see your notes.
Yeah.
Now, when it's continuous, it will tell you, it will say compounded continuously. Monthly is not continuous. Monthly means that N equals 12. Okay, so this formula for this problem is the future value, or the amount out in the future, is the initial amount, 1 plus your interest rate. Now your interest rate is 10%, but you have to convert that to a decimal, over N times T. In this problem, they give you all of the variables except for one. Okay, so if it's in the exponent, that's basically the hardest to figure out. So let's substitute some numbers and see what we got. So they want 6,200. They start with 4,600. 1 plus 0.1 over 12, 12 times t. So this is me just substituting in the numbers. A is the future value, P is what you started with, N is 12, and R is 0.1. So we're going to solve for t. To do that, you want to divide first. So it's 6,200 over 4,600. And then if you want, you can put this into the calculator, but you don't have to. It's yet you can do it at the last second. It's to the power of 12, but then this is very important. It's actually then raised to the power of t, even though this is a number. And the reason is, if you have an exponent to an exponent, you multiply them. So we're basically just going backwards.
Got it.
Now, to get a variable out of the exponent, you have to use natural log. So you take the natural log of both sides. This becomes t natural log of this mess inside here. 1 plus 0.1 over 12 to the power of 12. This is just a number. This natural log stuff, it just is a number. It's just not a number you like. You divide both sides by that, and you get your final answer here. Avoid trying to like change any of this. Just punch into the calculator this way.
Yeah.
and let the calculator do the work. Don't try to use any of the formulas we talked about earlier. They don't help here.
Got it.
Okay, ready to move on to 14?
Yeah.
All right, 14, I'll need to look up the formula for. So what's different about 14, it says that Alejandro contributes to a savings account monthly. So he's putting money in every month, whereas the previous problem is you put money in one time and you let it grow.
Yeah.
So I need to look up, this is like the future value of an annuity.
There's so the last one was the present value, right?
Yeah,
What's called?
that sounds about right. And so people that do finance stuff, they maybe know these formulas, but really you eventually just do it in your in a calculator.
Yeah.
Either they actually make financial calculators, or spreadsheets, or you can find stuff online. So the formula here that I'm seeing is the future value is the payment, and it's 1 plus r n minus 1 over r. Now, the thing that they don't do here, which really should, r is really the interest rate divided by the number of compounding periods. So in your case, it's 0.075 divided by 12, because n is 12.
Yeah.
And n really is an n. N is n times t.
Yeah.
I believe. So that's one of these problems with these things is you don't necessarily get the numbers. You have a formula, but it's not really spelled out for you. So you want 35,000, and you need to figure out your payment, but we got to get this inside stuff. So it's 1 plus 0.075 divided by 12. And then because it's 10 years, that's 12 times 10 minus 1 over r again is 0.075 divided by 12. And just be really careful how you calculate this. Like you almost need another set of parentheses here in the numerator. You get that number and you divide it over there and you get some amount. Now it should make sense. Like if he's doing it for 10 years, like if you get a number like 5,000, that's way too big. If you get a number like $20, it's probably too small. Because he's making 120 payments. That's, if you figure, if he just made a $30 payment 120 times, that's about 3,500. So it's going to be around $200-300 roughly.
Yeah.
What I'm basically saying is, like, if you take this number, divide it by 120, that's kind of where your number needs to be when you do this.
Got it.
Roughly, not perfectly. Okay. 15. 15 is the same. It's just solving for a different variable.
Okay, let's get that one then.
Okay. So as I said, we spent a lot of time on that one. We'll just move on here to number 1 on the next test.
Okay.
Find the radian measure for an angle whose measure is 35 degrees. To convert from degrees to radians, you multiply by pi over 180. And this produces 35 pi over 180. You do have to reduce that fraction to whatever it becomes. And that's really the only hard part of this problem is if you don't feel comfortable reducing stuff, which is 7 over 36 pi.
Okay.
Number 2. Simple pulley of radius 0.5 is used to lift a very heavy object. So the idea is here's a pulley here, and it's pulling, like you're rotating this thing. Okay, 810 degrees. So
Mhm.
810 degrees means you're going around 360 plus 360 plus 90.
Okay.
So every time you go around one time, it's 2 pi r.
Yeah.
So when you go around 360, it's 2 pi times 0.5. When you go around 360, it's 2 pi times 0.5. But 90 is not all the way around. 90 is a quarter turn. It's 90 over 360 times this 2 pi 0.5.
Hmm.
So it's 1 pi plus 1 pi plus this again is 1 pi, but it's multiplied by a fourth. So it's 2.25 pi.
Okay.
Similarly, you could get a problem like with a tire rotating. It'd be kind of the same here.
Yeah.
All right, evaluate all 6 trigonometric functions of the angle theta. This one is a Pythagorean triple, but if you didn't know that, I believe it is, you would do a squared plus b squared equals c squared.
Hmm.
And so that's 20 squared plus 21 squared equals c squared. Let me check this. It seems like it should be a triple. Yeah, it's 29. So c is 29.
Okay.
So then you got to be able to evaluate all 6 trigonometric functions of that angle there. So sine theta is 20 over 29. Tangent's 20 over 21. I'm doing it in the wrong order, sorry. So let's do cosine next. That's 21 over 29. And then really like sine goes with cosecant because they're reciprocal. So this is 29 over 20. Secant goes with cosine is 29 over 21. Cotangent's reciprocal of tangent. Once you know those, it goes real fast.
Hmm.
Any questions on that? Because you will.
No, I've got that one. Like, those are pretty easy.
Yeah. All right. We'll just keep going through. We'll be able to do a bunch of these in the time we have remaining. All right. Solve triangle ABC for all of its unknown parts. So A is 10 and C is 26. This is a 5, 12, 13 triangle.
Yeah.
So 5 times 2 gets you to 10. So B is really 24. And that helps you with doing the Pythagorean triples to make this fast. Now to find alpha, you have to use a sine, cosine, or theta. So like let's say you like cosine. Cosine of alpha is B over C. Cosine of alpha is then 24 over 26, which is really 12 over 13. To undo cosine, use a cosine inverse. So you definitely need a calculator for that.
Hmm.
Okay. Beta, you could do the same way, but the 3 angles in a triangle need to add up to 180. And since this is already 90, beta is 90 minus alpha. So once you get alpha, you can get the other one, or vice versa. If you like finding beta first, you do 90 minus beta to find alpha.
Yeah.
All right, number 5. Find the ordered pair on the point on a unit circle that is on the terminal side. They're basically telling you go to your unit circle, find 4 pi over 3, which is here, and figure out that ordered pair. So this is a straight, like, do you know how to find values on your unit circle?
Yeah.
If you're not comfortable with that, please take a look at it. There's not much more to it. Okay, find the domain and range. This next one, I'll just move through these a little quicker.
Okay.
Get through a few more here. So sine, as you know, it starts low, goes high, goes high. So the domain is always minus infinity to infinity for sine and cosine. The range, though, is dependent on this amplitude value. So normally the range is -1 to 1, but because there's 2, you multiply it by 2, you get -2 to 2 on it. If you had a vertical shift here, you would have to modify these numbers also
Yeah.
by adding the vertical shift to it.
Mhm.
All right, 7 is pretty long here. We're going to just go right to 8.
Okay.
What is the period of this function? The period is 2 pi over b. This is your b value, and this applies to sine, cosine, secant, and cosecant. So in your problem here, it's 2 pi over 5.
Yeah.
If I give you a tangent or a cotangent problem, the period is pi over b, not 2 pi. Small change on that.
Yeah. Okay.
Just trying to figure out what else
To do.
you might be asked to do. It looks like you've got some graphing problems by hand. So you
A
want to
lot
know,
of graphing the
yeah,
secant
make sure you know
all-
what all the parent graphs look like for sine, cosine, secant and cosecant, which come from sine and cosine, tangent and cotangent. They look kind of the same, but they're a little bit different.
Mhm.
The last one I guess we can do is this, I think. Okay, so cosine 17 pi over 5 on the unit circle, if you go all the way around, that's 2 pi, right?
Oh,
But
okay.
when it's with a denominator of 5, that means it's 10 pi over 2. I'm sorry, over 5.
Yeah.
So that means that you've gone all the way around once, and when you take 17 pi over 5 and subtract 10 pi over 5, you get 7 pi over 5.
Mhm.
Is that okay?
Yeah.
All right. Now, 7 pi over 5, where is that? Well, if you go, this is really pi, so it's really 5 pi over 5. So it's somewhere just past that. Like you go all the way around and then you go right to that point right there. So
Mhm.
that's like this little angle here is 2 pi over 5.
Yeah.
And whatever that is, we don't know what that is, but the cosine inverse of that, because cosine inverse is only defined in the first and the second quadrant,
Mhm.
you have to make a mapping of this. So notice that the value is negative, so it would end up being up here at this.
Yeah.
I mean, that's not a great not great on my part, but I guess that's yet another thing to remember is where cosine inverse is defined, and then sine inverse and cosine inverse. They're only defined over here. Don't know if that'll
Yeah.
help, but all right. Well, we did run out of time. If you have the ability to do some more review on your own, please do, or maybe
Mhm.
ask your teacher to help you out with some of these other ones here at the end.
Yeah.
All right, Ella, well, thanks so much for scheduling. Good
Yeah,
luck on your
thanks for your
exam. I'll
help.
send you the notes shortly, and I'll see you next time.
Okay, sounds good. Thank you.
Okay, bye
Bye.
now.